Newton's first law of motion, also known as the law of inertia, is one of the foundational principles of classical mechanics. It states an object will remain at rest or in uniform motion in a straight line unless acted upon by an external force. This principle essentially describes the natural tendency of objects to resist changes in their state of motion. The law emphasizes that motion or rest is not something that requires a force to maintain, but rather that a force is needed to alter it. The concept of inertia is central to this law. Inertia is the property of an object that resists changes to its motion. For example, a stationary ball on a flat surface will not start moving unless a force, such as a push, is applied to it. Similarly, a ball rolling on a perfectly smooth and frictionless surface would keep moving indefinitely in a straight line at constant speed without slowing down, as no external forces like friction or air resistance would be present to stop it. This highlights the natural persistence of motion or rest. Newton's first law challenged earlier views on motion, particularly those of Aristotle, who believed that a force was necessary to maintain motion. Newton's insights clarified that in the absence of forces, an object's motion is constant and changes only occur when external influences are applied. This shift in understanding was critical in moving away from misconceptions and establishing the framework for modern physics. This law has profound implications for the study of motion in various environments. For instance, in outer space, where friction and air resistance are negligible, spacecraft can travel vast distances without continuously expending fuel, relying instead on their inertia. The principle also plays a role in safety systems like seat belts, which protect passengers by counteracting their inertia during abrupt stops in vehicles. Overall, Newton's first law of motion explains the predictability of an object's behavior in the absence of external forces and sets the stage for understanding the dynamics of forces in his subsequent laws. It underscores the importance of external influences in shaping motion, providing a fundamental framework for studying mechanics and real-world phenomena.